if you analyze why the current tapes don't work, what you finally come to understand is that the gap that's required for a liquid to flow through or into is extremely minute. And the best example I can use is when they take a sample of your blood and they prick your finger and a drop of blood forms, and they take this little pipette, and this pipette has a hole in it that's about 10,000ths of an inch in diameter. And yet when they touch that pipette to the drop of blood, you see that blood shoot up into the pipette, okay? That's called capillary action. And those forces are very powerful. So when you use a conventional tape on a surface, all it has to have is a 10,000ths gap anywhere, and that can be just a crack in the paint for the paint to flow into that crack under capillary action. So what we realized was you quite literally couldn't have any gaps at all. You had to have a solid, complete wall as a barrier. And if you go down, when we did this, if you look at it with a microscope or a magnifying glass, when tape has been applied, you can see these little tiny gaps that cause the current tapes to fail. And so what we did with SNOT tape was we worked at developing this viscoelastic polymer that behaved almost like clay when you pushed it. So as you push it, it flows, again, like a combination of a liquid and a solid. And if you look at it under a microscope, you'll see that there are no gaps for the paint to flow through. And it's getting that adhesive to flow into that gap, stay there long enough so that during the painting process, that gap was blocked, and yet get the adhesive to remove safely afterwards. So it was this delicate balance of properties that were required to actually get it to function in the way that we knew in our minds we wanted.